Okay, let's get started. I think that we are on notes number 4 today, but correct me if I'm wrong. Sometimes I get off on my numbers. So what we're doing today is we're starting chapter 2. And chapter 2 starts out all about equations of lines and slope and y-intercept and all of those things, which I suspect you had a lot of practice with in Algebra 1, and you probably don't need a ton of practice. So what we're going to do is go through the first 4 sections and hit the main ideas from chapter 2, and then you're going to take a couple of days to do a lot of practice problems. So the topics are relations, functions, and lines. And the first thing we have is a vocabulary term. A mapping or pairing of input values with output values is known as a relation. Now, it might seem like a relation would be a set of inputs and outputs that have a relationship, like a pattern, but there's no pattern needed. It can be a random set of points, and it's a relation. And there are different ways that you can represent relations. So you could just list ordered pairs. For example, suppose we have 1, 2, 0, 9, -3 pi, 0, -10, 3, 2, etc. Okay? Any pairing of inputs and outputs is a relation, and you can list it as ordered pairs. Of course, we can't always list ordered pairs because sometimes we don't have a finite number of ordered pairs. Sometimes relations are represented as a table, so maybe an XY table, where you have all of your inputs in a column and all of your outputs in a column, whatever they happen to be. Okay? Sometimes a relation is represented as a graph, and it could just be discrete points. It could be something that's connected. It could be a combination of the two. It's just a set of ordered pairs. And then sometimes a relation is represented as a mapping diagram, where it's kind of like a table, but often you'll see kind of an oval shape that contains the inputs and an oval shape that contains the outputs. And you'll see arrows going from one to the other to show how these match up. Okay, so that is a relation. Now the inputs, the set of inputs, is known as the domain. And the set of outputs is known as the range. So I try to be really careful in how we use this vocabulary. The domain isn't a single input value, it's the set of all input values. So however many inputs are in the domain, chances are there's more than one, so it's the set of all of them. The range is not just a single output value, but it is the set of all the output values. Now, we have a special kind of relation, a relation for which every input is paired with exactly one output. And this is a really special mathematical relationship that's important because it's predictable. You have an input, there's only one output for it. Different input, there's only one output for it. And it is known as a function. So it's really important that you know this definition. A function is a relation for which every input is paired with exactly one output. So let's write down some examples of functions, and then let's make some up that are not functions so that we can compare them. So in terms of ordered pairs, you could have something like this. The ordered pair 1, 3, 2, 6, 3, 3. Now some people would go, wait a minute, how can you use 3 twice? Well, keep in mind that each input has only one output. It doesn't mean that you can't repeat outputs. You just can't repeat inputs. The graph could be something like discrete points or a curve, and we'll talk more about the features of the curve in a minute. But notice that no matter what x value you pick, it only has one y value. And then the mapping diagram could be something like this, 1, 2, 3, 4, 5. There's only one arrow coming from 1, there's only one arrow coming from 2, and there's only one arrow coming from 3. If you had multiple arrows coming from a number, that means it's going to multiple outputs and it would not be a function. Okay, so what's something that's not a function in terms of ordered pairs? Well, suppose you had, like I made above, 1, 3, and then 2, 6. But what if you also had 2, 3? Well, we have a problem here. It's not a function because 2 is mapped to 6 and 2 is mapped to 3. So there's an input that has multiple outputs, so it's not a function. And in terms of a graph, if you had something like this, looks kind of fun. However, there are some inputs that have multiple outputs. There's an x value there. I don't know what it is. Let's say it's a, and it has 3 different y values. So that would not be a function. And then for a mapping diagram, let's say we had 1, 2, 3, and we had 4, 5, and we had the point 1, 4, and 1, 5, and 2, 5, and 3, 5. Well, notice 2 arrows coming from the 1, so that means 1 has 2 outputs, so that is not a function. Okay, so here's a couple of problems we can figure out. You can even pause, figure it out yourself, and then resume. So is this a function, yes or no? Well, take a look at this portion right here where you have an x value, multiple x values that have multiple y values. So no, it's not a function. Now, even though it's not a function, it still has a domain and a range because every relation has a domain and range. So remember, the domain is the set of inputs. So graphically, we often think of it as the set of x values. So notice that this graph goes through all the x values from x equals -5 and on to the right. So we can say x is greater than or equal to -5. There's another kind of notation we can use. It's called interval notation. We would put a square bracket on -5, comma, infinity. Always use round brackets on infinity. A square bracket means include it. A round bracket means don't include it. So both of those are the same answer, just represented in different notation. Now, what's the range? So we're looking for the outputs, the set of outputs. So let's look at the y values of the points. Notice that the lowest point has a y value of -2, and then all of the other y values are higher. And because of this arrow, it looks like it's going to just keep going up. So our range is y is greater than or equal to -2. And if we want to put that into interval notation, we'll have -2 to infinity with a square bracket on the -2. Okay, let's look at the next one. And I apologize that my examples here are not numbered in this particular note set. Hopefully you're tracking anyway. You can number them if you'd like. So is this a function? Yes, it is, because every input has exactly one output. And what is the domain? Well, whenever you have just a discrete set of points, you can't use interval notation like this, because interval notation contains all infinitely many real numbers that fall between those two endpoints. So what we're going to need to do is just list the elements of the domain by listing the individual x coordinates, and set notation is you use these set braces around it. So we have -4, -3, -2, -1, and 0 as the x coordinates of the point. We'll do the same thing for the range. We have y values of -3, -1, 1, 3, and 5. Okay. Now, we have another term here. A relation is a blank if and only if no blank intersects the graph of the relation at more than blank. All right, well, you might have already been thinking of this when we were looking at these graphs, or earlier when we drew a graph of a function and a graph of a non-function. So if you have multiple points with the same x-coordinate as we see down here, then that means if you draw a vertical line through the function, it passes through more than one point there. I should say through the graph. It passes through more than one point. So if it's a function and you can draw a vertical line anywhere, it's only going to pass through the graph once, at most once. If it's not a function, then there's at least one place where a vertical line would pass through the graph more than once. So then to fill in the blanks, what do we call this? What do we call this test to determine if we have a function or not? We call it the vertical line test. Or just abbreviate it VLT when you're texting. A relation is a function if and only if no vertical line intersects the graph of the relation at more than one point. All right, this is actually a really good stopping point for part 1 of this lesson, and so I'll just make a video for part 2, and we'll talk more about things like slope and equations of lines.